Hello, friends. We are back with episode 209 of the Our Weekly Highlights podcast, and this is the mostly weekly show where we talk about the latest happenings and highlights that have been shared on this week's Our Weekly issue. My name is Eric Nance, and I'm delighted you join us from wherever you are around the world and being patient with us as always, as yours truly has a hectic schedule these days as summer starts to wind down. But as always, I am joined by my awesome co-host who never has a dull moment either, Mike Thomas. Mike, how are you doing today?
Doing well, Eric. We just rolled out a new Shiny Apps portal for a bunch of our clients, so we are shiny everywhere right now, which is very exciting.
I'm always here for it, and I saw your exciting press release earlier this week, so really congratulations to you and your a very talented team that hopefully I'm going to be seeing you obviously in PosiConf next month, and hopefully maybe see some of your teammates again too. We'll see. But nonetheless, I'm really excited to talk shop once again when we get there.
I can't wait.
Yes, I've already started the speaker coaching session. So it's that time. Got to get that talk squared away. So I've got some fun stuff to share too. But we got some fun stuff to share today. Speaking of sharing, yours truly will be a little vulnerable here for a second. Usually as part of my release process for each episode, I try to schedule the social media posts, and it was late at night. Usually when you do coding late at night or everything's late at night, something will happen. Yours truly somehow wanted to transfer time in the future to next year because I had 2026 as the scheduled year. So Mike, you definitely correctly said, where's the post? I never even bothered to check. Realized, oh, geez, they're stuck in the ether. So if you saw a note about the last episode a week later, the problem was not in the machines. It was what's sitting in the chair here. So you're welcome.
I thought it was going to be a lost episode that would come out way later. But nope, we caught it. No big deal. No harm, no foul. It happens.
Yep. Yeah, sometimes you need that extra hour of sleep before you send those out. So we probably will not have that happen this time around. You should see the notes the next day after I finish my fancy editing. So let's get the show on the road here. Our curator this week is Jonathan Caro, and as always, he had tremendous help from our fellow RWiki team members and contributors like you all around the world with your great pull requests and other suggestions. And we've covered this topic a bit before, but a lot of times when I develop either packages or applications at the day job, there is always the need, and I do mean the need for speed, as a certain actor said in one of his racing movies. And sometimes that becomes obvious when, say, you've maybe built that great Shiny app and then it's doing some crunching behind the scenes before you get that plot shown or that nice data table shown. You might be nice and at least put like a loading spinner in front of it, but then you may have a customer that says, what on earth is taking so long? Then you're thinking, okay, what is it really? Is it the business logic? Is it the UI element? What exactly is it? And a lot of times, at least in my practice, it does become part of the business logic problem, which means you're back to regular R code to try to figure out where this issue lies. So in light of that, our first highlight we're covering today is some really great notes from Kelly Bodwin, who has been a frequent contributor to highlights in the past. And she has this great new blog post on, I believe, one of her newer blog, actually. It's called Particles. Great name there. And the article is entitled Speed Testing and 3 different levels that you can take with your R coding. And this was inspired by a recent workshop that she jointly gave with Tyson Barrett from a USCOTS organization workshop. And this is inspired by a lot of material from there. And so to motivate the problem, she makes a little bit of a pipeline here of doing some various dplyr operations with an inflated New York City flights data set. In fact, she basically are binded rows, multiple times to get a much bigger set. And spoiler alert, like many of us, she does use a little LLM to get this example going quickly. And that's, very relatable. Group by processing, summarization, doing a little additional variable generation for different lengths or transformations, and doing some filtering afterwards, and some sorting. This is all very relatable data pipelines. And so that might take a while because of it is a larger data set. So before you can really do a lot of testing that's recommended here, or benchmarking, if you will, it is helpful to put all this in a function for convenience. So she ends up doing that with an appropriate name, do the thing function. And I love these kind of names because sometimes in my mood, I might name a function very random words as well. First level is basically the time itself. That's often where we start to see there might be an issue. So that might be your first pass, if you will, of just how long is something taking. There is a recommended approach, but if you're especially using R for a while, you may be aware of the sys.time function, where it literally just gives you the actual time when you run that function. And you can save that as a variable, run your long-running function, run that sys.time again, but then do arithmetic and minus what you recorded as a start time. That is fine-ish, but she correctly points out you're getting an object back called the diff time object, and it's not really user-friendly from what she wants to do, which is more arithmetic around these operations. So there are some better functions to use, in her opinion, which are both in base R, called proc.time and system.time. So if you just swap out sys.time and proc.time, you'll get now an actual proc.time object, which is a named vector, which is great because you also get the elapsed time right off the bat after you do your arithmetic of the start time minus the end time. So that's a little more relatable. And again, this is human type of seconds that are outlined here. And then you may be familiar in the R community, some of the wraps kind of this proc.time stuff, the tick package and the tick-tock function to be exact. So you can basically flag it as tick, do your function, then you run another function called tock, and immediately you'll get the time elapsed right off the bat in the console. This is great for more of those interactive type of explorations at the time. And it might lead to more investigation depending on that complexity of the function. But you can do some pretty interesting things with the result of that object too, if you're daring to do so. But that may not be quite enough. So you may have found the slowdown. Now you want to know, well, what can you really do to interrogate this instead, and maybe look at alternative solutions to that alternative code. That's where benchmarking comes in. There are a few different ways you can do this too. First of which is, first of all, having that alternative function to have something to compare it against. And because Kelly's been involved with a lot of the DT package, might say a reinvigoration, or at least trying to bring that more to the mainstream of the R community, she makes a handy function called do the thing DT, where she basically takes the DT plier package, compares that existing data set to a DT object with lazy_DT, does the same dplyr operations, and then returns out. So that's a nice little convenient thing if you want to still keep your dplyr syntax, but take advantage of data.table functions. So with that, there is a package called microbenchmark, where you can run iterations of these same functions multiple times. Because if you run the function once, depending on what your system's actually doing, you might get different results the next time you run it, right? Because maybe your browser is going crazy on you. Maybe you got another, data hungry process that's doing stuff. So having micro benchmark do a set, like a controlled experiment, if you will, running each of these things, say 100 times, you might get then the average, the mean or the median of these times and resources used. So that's great. Now keep in mind, it's going to run the code a lot of times, so I might have to sit back and do something else while it's crunching through that. And that can show in this case that the DT data.table version of her function here reduced the evaluation time quite a bit. So that was pretty neat. But you may want to see, is that really going to generalize to even bigger data sets? So you might want to make different versions of your inputs. And then that's where you might want to opt into the bench package, which has, I think this is an offer by Jim Hester, formerly at Posit, now I believe at another company. And this is where you can do the mark function from bench and use these set of functions, but also maybe a different input or different inputs throughout this process. And there is, again, a way to do this with the mark function, and you'll get similar elapsed times as you would for the other micro benchmark function. But this only runs something once when you do that mark function. It might be just helpful for prototyping, but the reason she wanted to do this is you get the memory results, not just the time results. So that might lead to, oh, wait a second, the DT version is using roughly half the memory as the default dplyr version. So is that going to generalize to larger data sets? And that's where the press function comes in, where you might, in this case, say, have these different scenarios of different sizes of the data and still use the mark function under the hood to do it, but then you're basically making these different versions of the flights data set. And then that's where she could see that as the data got larger, this advantage of data.table versus dplyr wasn't really growing at the same growth as the data set got larger. So it's not quite as fast in the larger data sets as it was on the slightly smaller set. So that's where looking at the bench package gives you some additional insights and little ways to control your experiments even more. Last but certainly not least, and probably the most complicated of this, is that you want to really figure out in a fine-tuned way where these potential bottlenecks are actually happening. Instead of just bigger wrapper function, where is this actually happening? And that's where profiling comes in. Something I need to do more of, but also become more comfortable with the workflow here. You got a few options here too. You got the ProfViz package offered by Winston Chang over at Posit. This has been great for both traditional R code as well as Shiny code for that matter. And you can feed in this case, kind of the body of this function that Kelly's made here. And you get the nice kind of flame graph that's interactive, and you can start to see that most of the time being spent was on the filter statement. That often is a bottleneck in traditional dplyr pipelines. But it's great that you can at least explore this interactively, even in the blog post itself, toggle between the flame graph and the actual data that shows like the steps in a collapsible list. Really nice to see ProfViz being used here. You can go even more lower level than this with the rprof function in base R. In order to do that, you still need to save your results out when you run rprof, and then you'll have to create a helper function of sorts or use a summary rprof function to do that, as she has in the blog post, where you can see roughly similar output as ProfViz, but that may be helpful if you want to stick to that native rprof structure. There are some additional packages in this space, and in fact, Proffer, authored by my colleague Will Landau, is a great package in this space. So check that out if you're interested. He saw some shortcomings in ProfViz, so he thought he wanted to take it to another level with Proffer. And if you know Will well enough, you know that when he gets his hands on something, he will make a nice interface out of it. Kelly concludes the post with some other additional thoughts about maybe in the future, profiling can be easier with maybe a pipeline kind of syntax. She shows some kind of pseudocode that she does to illustrate this in a more manual way. Maybe someone will take on that challenge. Who knows? But I hope this post illustrates to all of you, you've got different levels, if you will, of doing this kind of benchmarking and speed testing exercise. Sometimes just a time elapsed might be good enough. Other times you got to go a little further, and that's when you got to put your design of experiments type hat on with the bench package and micro benchmark, and then really start to get lower level if you need to with the profiling tools. They can be quite rabbit holes, so you got to right size this to what you need for your given project. There may be cases where you just can't do anything anymore, and you got to communicate that to your users. But you might see some significant gains of how that data is being stored or the types of processing you're doing. Things like data.table are definitely a big help, but there may be more you can do. Certainly things like DuckDB and dplyr have my attention to make data operations even more faster than potentially this. So again, great if you're new to this space. And again, some good nuggets to dive deep further if you want to, go down the rabbit hole, as I said, in each of these different levels. So as Kelly always does, she teaches me something new every time she writes a great post here. So Mike, what did you learn from all this?
Yes, Kelly Bodwin, former Shiny in Production workshop attendee, asked great questions, asked me questions
right.
I couldn't answer because I think she's smarter than me, which doesn't take much. But the blog mentions that ChatGPT wrote the data wrangling pipeline code, and I can't help but wonder, did Kelly do some vibe coding here? I guess that's sort of the big thing these days. I have not stepped into it.
For you. Yep.
But throw that out there. I am really guilty of using sys.time, which is, as Kelly points out, is a lot more fragile than some of the other options that we have, even just in base R, like proc.time and system.time. Or, that TikTok package, it's one that's been around for a while. It's just, it feels like one of those tidy packages that just makes the output a lot neater and user-friendly for us when we're trying to do these types of exercises. And there's some great use cases, and I never really thought about all of the nuances where you may want to employ, profiling, benchmarking, comparisons of the time it might take to run your pipeline. But as she mentions, and you mentioned, Eric, if you're looking to do experimentation and run your code a ton of times, because we know it won't take the exact same amount of time each time, right? It could just be millisecond differences, or it could be longer, depending on what you're trying to do. You can see a distribution of those runtimes with that micro benchmark package, which can really be your friend. I think by default, it runs your code like 100 times and shows you summary statistics on how long it took across that distribution. And if you want to compare, trying to do the same thing a couple of different ways, one example I could think of is if you have a dplyr pipeline and a data.table pipeline that are trying to accomplish the same thing, you can use the bench package, which can be your friend in those situations. And there's always something for me just kind of oddly satisfying when I see these clever namespaced functions like bench : mark or bench : press. There's a few other packages out there that I think are clever in how they name both the package and the functions within that package, so that the package and the namespace version of the function is, I don't know, it's just one of those things that makes me smile. And speaking of that 2023 Shiny in Production workshop that your favorite podcast host taught, ProfViz, as you mentioned, Eric, provides some really powerful visuals and graphics about the time it took to run each part of your pipeline. And it takes some education to figure out how to interpret the output of ProfViz. Once you do figure that out, it's really powerful. But as you mentioned, I wonder if we could make this prettier or more interpretable in the future, if there's a way to kind of clean up what ProfViz returns and just make it, I don't know, feel like it's in the year 2025 in a way. I feel like that's got to be possible. I'm kind of making my own call to action to maybe step into that package and see if I can submit a pull request to clean it up. But that's probably some serious code and probably a little bit above my pay grade, but we'll see. Just throwing that out there into the world. And it may not be important to you in a lot of situations that you're in to get your code down from maybe like a 2 minutes runtime to 1 minute. But if you have, for instance, like a cron job running every day on cloud compute, it can actually save you a lot of money in the long run.
Great point.
And it can just be, these things add up over time. So taking the necessary steps and just being thoughtful about how long your code is running for, where the bottlenecks are, and just trying to write the most, concise but legible code. That's something that we really try to practice day in and day out on my team. And it can be really important in the long run if you look at the big picture. But great blog post from Kelly, and it's a great reminder on a subject that I don't think we talk about enough.
Yeah, and a lot of times maybe in a more interactive data analysis, you're certainly not really thinking of these issues. This is when you get to those ETL kind of processes or anything that involves heavy business logic in your interfaces, whether it's packages or apps, or definitely a combination of both in my cases. A lot of times the biggest wins are when you find that even after all this, you still can't really do a whole lot to minimize the execution time. if you do have an opportunity to somehow cache these things or run them on a schedule, and then say your app consumes them, on the fly, but that process, heavy lifting's already been done, and the app is simply importing them. This little free consulting for those out there that may be struggling with this. Packages like pins, if you can do your data ETL stuff and then put it as a pin as your summary or transform set, have your app consume that instead of the app doing all that, oh goodness, the time gains can be immense. And that was a recent project that I'm about to put in production in the coming month. That's been our biggest win. Just cache all those results. The app itself didn't need to do any of that stuff on the fly anyway. And now I run a cron job that right now is every night, or every morning, I should say. But I got the capability of running that even more frequently if I need to with cloud architecture. So it's little things like that you kind of learn on the fly. But even before you get to that point, if you can speed things up, these are some great tips to do so. And as I just mentioned, Mike, trying to do things outside your app is a really helpful technique. And a lot of times being able to separate out the way your package or your app is calling an analysis, requirement or analysis function that gives you more control on, the rest of that process can be really helpful too. You and I have both been knee deep in our recent projects and either building or consuming, or frankly, both building and consuming custom APIs, application programming interfaces, if you haven't heard that term before, in our various utilities or innovation capabilities we've been building here. And in the world of the art community, a great way to build your own API has been the Plumber package. That's had many years of history now, but boy, it's been a lifesaver for me when I wanted to democratize, if you will, the use of this analytical pipeline or resource. So certainly from R, I could call it from Python, could call it from anything that can do a curl request. Plumber gives you that opportunity. So you may be building this great API, but then it comes a stage where if you got to put this in production, they're going to ask you, where's the test? What do you want to do for testing? You could go down a lot of different directions for this, but this next highlight talks about some really great points for you to consider, especially as you structure, your testing paradigm and some common pitfalls that you can avoid here. And returning to the highlights once again, comes to us from Jacob Sobolewski over at Absalon, who's been, as you may have heard in previous episodes, really active in the space of testing on the Shiny side as well as on the general R side. And this blog post he has here is called Testing Your Plumber APIs from R itself. And so there is basically first set of advice in this blog post that I think can relate to us on many levels. It's a given that your API probably is going to do some kind of business logic type function, whether it's data processing, whether it's munging, whether it's just making new variables or whatnot. And that doesn't necessarily need to be tested in the same way as the API interface itself. So his first piece of advice is called the separation of concerns. For that business logic stuff, put that in its own function and use what's familiar to many those in the R community of the test that package. Use that framework that's been well established, doesn't have anything to do with the API interface at that point. Get all that stuff ironed out first in the more traditional testing paradigm. Same thing applies to Shiny itself for that matter. Get your business logic into functions, test that with test that. Your life will be a lot easier. That gives you the ability to tailor the API kind of testing, which he calls API contract testing. Not so much focus on the exact response that you get from the API, because that's going to be handled from the business logic stuff. This is more about what he calls the shape of the response. Is it the type of structure, say a list structure, maybe it's a data frame structure. And so having these two different layer approaches, you got the business logic layer and now this API contract layer to really compartmentalize these two perspectives. So you may be thinking, yeah, I can handle the test that framework. Now, well, how do I get started with this kind of API contract testing layer? The first step is just getting the API running of itself. So as many things are, by default, things run in the foreground when you run like a long running function. Heck, when we run a Shiny app interactively, that's in a foreground process most of the time. So you want to run this API, this Plumber API process in the background. And that's where, this is where I started to learn some interesting use cases. The Mirai package, authored by Charlie Gao, who is now a solution engineer at Posit. This package is great for launching a Plumber API as a very straightforward backward process. I remember in the past, in the Plumber documentation, they would say, okay, spin up another R process, run this Plumber process on the fly manually, go back to your foreground process, and then run your like curl calls or whatever else to interactively spot check the API you're serving. So this is a great way for Mirai just to get that thing running in the background and then get on with your actual testing paradigm. Next, he recommends a new pattern, or at least new to me the way he articulates it, for the way you test things. So you first got the arrange part of this, getting your API as a background process, get your test data ready to go, and then setting up whatever you need from a configuration or authentication standpoint. That's your setup time, if you will. Then, once you got all that boilerplate set up, the background process, the authentication, now it's time to actually do the thing, as I say, and make the actual request to your API using a package like HTTR2, Hitter2, however you want to pronounce it. This is great. That is only just running the action that you want to test with the required parameters in your API. Last but not least, you've got the assert phase. And this is where you're going to look at making sure that you're getting the expected types of results. And again, maybe not the result itself, but the shape of it, the type of response codes, the status codes, you might say. Is it a 200? Is it a 400? Is it a 500? Is it, and again, the structure, making sure it's fitting the structure, not necessarily the in-depth content of the response itself. So though that in and of itself, that approach really resonates with me. And then also looking at how you structure all this, he's got to recommend a naming pattern of like test-API-endpoint, whatever that endpoint ends up being for the individual endpoints, but keeping those in isolation from each other instead of doing one script that does all the endpoints at once. So it's a great way to focus yourself well on that particular endpoint and then running the associated maybe business logic test alongside with that, but in that layered approach. And that can make debugging easier, can make setup easier, and a lot of things like that. And then, he's got some other helpful information about, again, the idea of testing the shape of the response, not the content itself. You may not necessarily care what a slot called ID or name, what those actually are, but what are the attributes of that? What is the logic in that? Use the business logic for the actual values. And then lastly, he concludes with some pitfalls to avoid that can be difficult to avoid if you're new to this. Trust me, I know. Is making sure you don't necessarily duplicate the business logic type of tests in your API tests. Like those should be kind of self-contained, their own function, their own tests, and you just simply call them as needed. And then really, hopefully, you're not so much testing the implementation detail itself. It's more about the API endpoint. It should not matter necessarily if you're using Hitter2 to do it, if you're using a straight system curl command to do it. That should not matter. An API call is an API call one way or another. And then hopefully, this is probably the hardest to avoid if you're in an organization. Hopefully, you don't have to depend on an external service to actually conduct the API testing. But if you do, use it only when you absolutely need to, and maybe take advantage of things like mocking or other helper packages to kind of cache what that setup, external process looks like, and then use that mocked function in your testing instead of having to do that repeated call to that external service to make that happen. So Lots of great advice. And then also in the supplements I'll put in the show notes here, he's got a handy set of examples in what he calls the R test gallery, which I think he's had this for a while, I just wasn't aware of it. And you can go straight to examples for the plumber API test. So it opens this little editor right under the blog post where you can kind of look at this almost like an iframe thing, I guess, through GitHub or something. And you can literally see in this hypothetical example what he's doing to illustrate the concepts in this blog post. So really convenient way to kind of see how all this relates to each other. I've been building a couple custom APIs at the day job, so I've learned a lot through this, and I've been using some of the best practices already. But certainly I've learned a thing or two about this recommended pattern of how to use this arrange, act, and assert pattern when we think about constructing these API level tests. So great blog post here by Jacob as always, and he's quickly establishing himself as a real key thought leader in this space. I'm going to be reading this definitely again after this show. So hopefully you learned a thing or two, Mike, from this. But I know you've been knee-deep in API development lately. What did you think of this?
I did, but Jacob always delivers, seems like a whole lot of blog posts lately. Really interesting content, particularly around testing. And I couldn't agree more with the beginning of this blog post. You've got to separate your business logic from the service itself. And I'd preach this if it's a plumber API or a Shiny app. I think it makes sense to do so in pretty much all cases. One thing that I was reminded of as we started reading through this blog post is there's a Plumber 2 potentially coming. That is a rewrite of Plumber, right?
Yes, that is coming. I mean, Thomas Lynn Peterson sent a note about that a couple months ago. Yeah.
Yeah, so I see that out there. It has not hit CRAN yet. It has no tags yet. I haven't taken a look at when the most recent commit was made. Oh, last week. So it looks like it's still under active development. And I wonder if some of these concepts that Jacob's talking about in his blog post may be introduced as features in the Plumber 2 package as well. We will have to see. I haven't looked under the hood of the Plumber 2 code enough yet, but just some food for thought out there. And I love the arrange, act, assert pattern Jacob mentions. Writing unit tests for status codes can absolutely be your friend. In my experience, it can also be your enemy if you're too generic.
Yes, so, absolutely.
Just a little word to the wise out there for all those 300, 400, 500 status codes that could come back. One flavor of a 400 status code could be quite different than a different flavor of a 400 status code. If you've been there, you know what I mean. And also, in my experience, the with R package can really be your friend in unit testing for creating like sort of an isolated environment that you can throw away when the unit testing is done, or this environment that's sort of separate than the development environment that you're using for your package to create sort of these really interesting temporary environments. I think we've talked about a lot of use cases in the past where that may help. And Plumber or Mirai may already sort of offer that same functionality, or they may import with R in those packages. I wouldn't be surprised at all. I don't have a whole lot of experience with Mirai. I should. So I know that it's great for spinning up multiple R processes, which can be great for parallel processing or concurrent requests. We don't have any APIs right now for our clients or internally that get hit really hard. So none of them we've found the need to allow for sort of concurrent processing yet, but if everything goes well, we will one day. So, exactly. And nanotech seems very interesting for that exact topic, right? Concurrent request handling. And this all reminds me of Jacqueline and Heather Knowles' talk. I think it was called, We Put R in Production. And they literally had like in a neural network, I think, API that they had stood up with R that was getting hit by the customer service team at T-Mobile like a million times a month or something like that.
It was an obscene number. I couldn't believe it. Yeah.
And it was working great. So maybe I'll try to add those slides to the show notes because I think they had a website it was literally just called Put R in Prod. And we'll try to link to that website, but it was one that when all the language wars stuff comes out about R's slowness, once in a while, I always just fire off a link to those slides and that website to prove that that is all bogus. But great blog post by Jacob. A lot of, I think, really interesting nuggets to take away for your API testing use cases.
Yep, loved every bit of this, and like I said, learned a lot along the way. And one thing I'll plug in this space that I think can be a great accompanying to this is that there's been a new release of a package in this space by Scott Chamberlain called VCR. This is a great package that lets you record and replay these various HTTP requests that you might make if you're doing an R package that surfaces an API. This is a great way to test that. So I definitely recommend that approach, maybe to augment with it. It's got a nice straightforward way to augment test that with this functionality. So lots of great tools in this space I should say. And a great thanks to Jacob for continuing to pump the knowledge into our veins of how to do this in an innovative way. All right, and lastly, to round out the highlights today, admittedly, this one's going to be a little more difficult to talk about because it's actually a video tutorial, but it's a space that we often touch on in this show about the clever uses of visualization in R to replicate or perhaps even make better a lot of these fancy visualizations you might see in the reporting space. And in this case, this last highlight comes to us from, again, a video tutorial created by Spencer Shin, who is a data and policy strategist at the City for Collective over in Wisconsin. And he saw a bar chart in the New York Times online blog. Be warned, if you do try to link to it or click the New York Times link, you might get nagged about making an account. So if you get that, just like I did when I was preparing for this, we have a link in the show notes to the GitHub repo that Spencer created for this code demonstration that has the actual image in there for the plot. But admittedly, the plot itself, the subject matter is a bit political, and I've had a hard enough week already, so I'm not going to get political on you all. There are hundreds of other podcasts to listen to if you want to get in on that train, but it is a bar chart about the new bill that's been proposed by the president, called the Big Beautiful Bill, and the way it could potentially impact different income brackets in the next 10 years or so. So with that, it's a pretty straightforward bar chart with each threshold income is a separate bar, and the bar goes down below the x-axis if it's a negative threshold and goes up if it's a positive threshold, or positive change, I should say, in the resources. So in the video tutorial, I'll just kind of give a quick take on what Spencer did and some of the things I learned from it. There was a hyperlink to the source data in the article, but actually the data is in the chart itself. It's annotated above each bar. So he made a simple table for each income bracket, the average threshold change or the income, so to speak. Just made a table out of it. Brute forced it, but hey, it works. And then after that, the finished product on the GitHub repo looks great, but he didn't start there. Started with a very basic ggplot, very bare bones, no updates to theming, no updates to anything. And so he illustrates what does he change along the way to start getting it to replicate the New York Times visualization. He first, again, made the data generation a bit easier, starts to think about, getting the default theme out, changing the colors of the bars using, of all things, the developer console in the browser at the article to pinpoint where the colors are actually used in that online visualization, which I'm sure was using some web GL or web framework to do it. But the CSS is all there. So you can grab the colors, start to update the theming of the code itself. There was a lot of interesting things. He was using positron for the first time, so there are little gotchas of the editor that he showed and fast-forwarded parts that he felt were a little off, so to speak. But it's a great very much in the style of live coding, how he made this tutorial. So I can relate to it. I've done a few of those in the past, so definitely fun to see somebody flex their visualization knowledge. But honestly, it's native ggplot with the scales package. That's it. Like, it did not take a huge effort other than using some custom fonts to get this ggplot version of the chart to look like the New York Times article. So if nothing else, it's a great illustration with just like a handful of time, about a half hour screencast. He replicated this chart all with what ggplot 2 offers. So lots of clever use of the theming, the text representations, and all that. So check out the show notes. You'll get a link to the code. But yeah, have a look at the video if you want to see how an expert does this in action. So pretty fun stuff there.
I feel like data visualization blogs and videos and things like that, they always offer something that you hadn't thought about before, right? Like there's sort of an unlimited amount of creativity that can go into the concept of data visualization. And this is, a really cool exercise to go from scratch, something that he saw in the New York Times, to trying to build it yourself in Positron. And as you mentioned, love the live coding idea. Eric, that's a road that you have gone down many times. I have never live coded before. I am way too scared, but I think it's incredibly beneficial to people who watch live coding exercises, because they can see the little hiccups that you hit and how you thought about debugging them right on the fly. And sometimes someone else being able to just visualize that thought process can be more helpful than following this set of instructions on how to get around it. So
yes, we are all human beings, my friend. No matter what you may think when you see the finished code, we are all humans, and how we get there is not always the smoothest experience.
Kudos to Spencer, absolutely. One really sort of interesting thing about this particular chart that lends itself to telling the story of how flexible ggplot is and how customizable it is the output plot here has sort of data labels on both sides of the bars. Right. It has data labels, for the positive bars, it has data labels above the bars, and then for the negative bars, it has data labels below the bars that represent sort of the value, right, the height of each of those bars. But it also has these sort of annotation data labels that I believe represent like the quartile or something like that of each particular bar, that are on the opposite side of the value data label. So for the negative bars, it's on top, and for the positive bars, it's underneath it. So you would think that that's a whole lot of data labels going on the same chart here, but it's actually really clean and really informative. I thought that it was pretty incredible that he was even able to pull that off. And if you take a look at the code, I think the final piece of code is like 38 lines of code to pull off this New York Times bar chart with all
it's
ggplot.
amazingly concise. Yeah, it's just amazing what you can do with ggplot too.
I think that's sort of the long story short here. Amazing what you can see with what you can do with ggplot 2. Love the concept of bringing in the exploration of sort of the browser dev tools, right? Being able to take a look at the New York Times website itself and grabbing, those exact CSS color elements off of the page and incorporating them in the ggplot 2 code. Really handy trick for some of the data viz folks out there that might be a takeaway. And I'm sure there's plenty of other things in this particular video here that you could gain a lot of knowledge from. So hats off to Spencer.
Well, couldn't have said it better myself. So again, lots more in this week's Our Weekly issue. And again, check out that screencast. Again, it's a very entertaining style that Spencer has, and I can relate to it on many levels. But yeah, we better get out of here soon. Our day jobs are calling us once again. But again, if you want to get in touch with us, we have various ways of doing that. First of all, we appreciate your input on the Our Weekly issue itself. If you're new pull requests for that great new package, resource, blog post you found, I have a few, and I might be next up for curating, so I can need all the help I can get. So that would be great. You can also get in touch with us with the contact page in this episode's show notes. You can also find us on the social medias. I am on, in fact, you know what? Check the show notes. You hear me say it enough. You know where to find us. Just look in your podcast player. We're all there. So with that, we are going to close up shop here on our Weekly Highlights, episode 209. And we'll be back with hopefully episode 210 of our Weekly Highlights. And again, hopefully, you never know the way the summer goes, next week.